back. Problem 7, start 5-2. A fair coin is tossed 3 times and the events A, B, C are defined as follows. A, at least one head is observed. B, at least 2 heads are observed. C, number of heads observed is odd. Okay. Probability of not A. A, at least one head is observed. So here is a drawing. You start your experiment here. First flip, you have 2 options, head, tail, with probability of half each, 50%. 1/2, 1/2. Second flip, if the first is head, well, the second could be head or tail. Again, you're going to get half, half here. Third flip, head, tail, half, half. Likewise, if first is head, second is tail, then, well, third could be head or tail, half. So basically, each of these branches get 1/2. All right. Not A means, what is A? At least one head. Not A means no head. No head means tail, tail, tail. Each of these branches have half. So I'm going to multiply half times half times half. So 1/2 times 1/2 times 1/2. Notice I've placed 1/2 in parenthesis and I'm multiplying 3 times because there are 3 branches in this entire sequence. So that is the probability of not A. Not A means no head. No head means all tails. All right. B part, A or C. A tells me at least one head. C tells me number of heads observed is odd. So A is at least one head, which means all branches minus tail, tail, tail. How many branches are here? Notice 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sequences. Of those 8 entire final sequences, you have to take away tail, tail, tail. So there are 7 sequences in A. So at least one head or number of heads observed is odd. Well, number of heads observed is odd means one head, right? HTT, THT, TTH, or 3 heads. These are odd number of heads. All right. But notice they are all mentioned here already. So A contains C. I don't need to count this again. They have been counted in A already. So A or C is simply A, which is 7 times 7 sequences. Each sequence, as we just saw, is half times half times half because each sequence has 3 branches, right? H, 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 T, H, T, H, H, T, T, so on. These are all branches. Each branch gets a probability of 1/2. So A or C gets a probability of 7 times half times half times half. The next one, probability of not A. Not A means no heads, which is tail, tail, tail. Or B. B is at least 2 heads. At least 2 heads. Here, 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 there are 2 heads and here are 3 heads. And not C. Not C. C is number of heads is odd. So not C is number of heads is even. TTT. So H, there are 2 heads. So notice all these are repetition of what happened previously. TTT is here. HHT, HTH, and THH, they are here. So I don't need to count these again. So how many in all? 1, 2, 3, 4, 5. 5 times all of this. Half times half times half. Okay? Next problem. Okay. 2 marbles are drawn randomly, one after another, without replacement from a jar. Okay. Okay. This also will require a picture. 8 red marbles, 8 white marbles, 5 yellow marbles. So let's draw a picture for this. So what do we have? 8 red, okay, 8 white, and 5 yellow. Okay, so we have these marbles in a jar, and we are drawing 2, one after the other without replacement. Find the probability of the events. So first draw, you could have either a red or a white or a yellow option. Okay? If you drew a red first, you might still have these 3 options left: red, white, yellow. This is the second draw. Likewise, this is the second draw for white: red, white, yellow, and this is the second draw for yellow. Okay, so we got the picture done. Now, the probability of each branch. 8 red out of total. How many are here? 8 plus 8 is 16, plus 5 is 21 in all. Okay, so notice one has to be careful. The first time I draw a red, I have 8 reds out of 21 in all. The second red, if I have drawn a red, then only 7 are left over. And I have drawn 1 marble, so 20 are left over. Okay, that's how you assign numbers. For example, yellow. The first yellow, say 1. There are 5 yellows out of 21 in all. So the first draw, I have 21 marbles. Now suppose I get first a yellow, then a red. So I drew a yellow, so none of the reds were drawn. So red continues to be 8, but I drew 1 marble from 21, so 20 left over. Okay, so this is how you are going to, so the numbers are not going to be the same. Like in the previous case, here each branch numbers will change. So based on that, we want to study this. A red marble is drawn, R first, followed by white. So red got me 8 over 21 times, now white. So I drew out a red, but 8 whites are still left. So 8 over, I drew out 1 marble, so in all 20 left. Okay. Likewise, the B part, first white, so white is 8, 8 out of 21 times by another white. So 8, 1 of the white is gone, so 7 are left. 1 of the marbles is gone, so 20 are left. The next one is a yellow marble is not drawn at all. So you don't want either this branch or this branch or this entire branch. You don't want any of this. Okay, so what do we want? 1, 2, 3, 4. These branches you want. All right. So let's play with them. The first branch is 8 out of 21 times 7 out of 20 plus the second branch 8 out of 21 and 8 out of 21 8 out of 20, I'm sorry. Second draw, I have only 20 marbles left. I want to make sure that's correct. So that took care of this and this. Now here there are 8. By the way, these two are the same number, so you're going to get the same thing again. All right. So let me copy and paste everybody. And add it all. Okay, 8 red, 8 white. All right. Next problem, I'll continue on the next video.